The shapes of molecules are determined by the repulsion of valence electrons, both lone pairs and bonding electrons. VSEPR stands for valence shell electron pair repulsion theory, and it states that valence electrons in molecules orient themselves to minimize repulsion. To determine the shape and bond angles in a molecule, first determine the number of atoms that are bonded to the atom of interest. Next, determine the number of lone pairs on the atom of interest. And 3, look at Table 3.6 in the textbook. Here is Table 3.6 on this slide, and we can see that if there is an atom of interest that is bonded to 4 other atoms, and there are no lone pairs on the atom of interest, the shape is tetrahedral with bond angles of 109.5 degrees. If the atom of interest is bonded to 3 other atoms and has 1 lone pair, the shape is pyramidal and bond angles are less than 109.5 degrees. If the atom of interest is bonded to 2 atoms and has 2 lone pairs, the shape is bent and there is a bond angle of less than 109.5 degrees. If the atom of interest is bonded to 3 other atoms and has no lone pair, the shape is trigonal planar with bond angles of 120 degrees. If the atom of interest is bonded to 2 other atoms and has no lone pairs, then the shape is linear with bond angles of 180 degrees. Let's apply these steps to determine the shape and bond angles of the polyatomic ion carbonate and the molecule ammonia. The central atom in carbonate is a carbon bonded to 3 other oxygen atoms with no lone pairs on the carbon atom. The central atom in ammonia is bonded to 3 other hydrogen atoms and has 1 lone pair. Pause the video to determine the bond angles and shape of each species. We remember to determine the number of atoms bonded to the atom of interest, then the number of lone pairs on the atom of interest, and then we look at Table 3.6 in the textbook. The carbon in carbonate is bonded to 3 other atoms and has no lone pairs, so its shape is trigonal planar with bond angles of 120 degrees. The nitrogen in ammonia is bonded to 3 other atoms and has 1 lone pair. Its shape is pyramidal and there are bond angles of less than 109.5 degrees.